Yeah, so once again, hi to you all. Thanks for having me here. My name is Dudczak, and this is a presentation about JUnit. So think which is not the newest and shiniest framework around, but we will tell a bit more about this later on. It is my first time on the Atmosphere, so I would like to briefly introduce myself. I work as a software engineer in Allegro.pl. I have a quite long-lasting love affair with Java and JUnit. I am also very active in Poznan Java community, and it happens that I am also a co-organizer of a conference which took place last week in Krakow. I am a co-organizer of Geekon. Some of you may have a chance to be there. So the question is, most likely, which is somewhere in your mind, and also especially of those of you who have visited the presentation in the previous session about Spock, why the hell I am still talking about JUnit? Yeah, the JUnit was one of the things which started TDD revolution, if we can say that there was any sort of thing like TDD revolution. So it is a bit grumpy. It has a long beard, as I have. Spock guys didn't have beard at all. And why to talk about JUnit when we have much modern and more flexible alternatives? So my initial idea was, there is no Spock guys and girls, of course. So just keep walking. This is the thing which I know, and I will tell you a bit, but let's not be silly. If I would start a new project, I would definitely use Spock, because this is a modern tool. But in some cases, we are still very much interested in using JUnit. Some weeks ago, Rebel Labs, which is a portal from Zero Turnaround, they from time to time they are surveying developers. They are asking questions about tools, about technologies, about approaches which they use, and they have surveyed Java developers asking what tools they are using. So as you see here, or maybe you don't see, I find myself constantly surprised by how my new computer works. So let's go to the why JUnit is relevant. So they were asking developers about what tools do they use, and for quite a significant % of people, JUnit is still a valuable tool. And that's why I think that the knowledge about some patterns which I will cover in this presentation might be interesting for you and might be useful in your work. So the first thing, this presentation will be code-centric. As my colleagues said in the session before about Spock, JUnit is in fact a code-centric tool because it is focused on unit testing. It is not focused on business testing. The first and the primary application of this tool was to write unit tests. So I will show you quite a lot of code. So this is today we will work with this class, which is ERRORRATE. Quite simple logic. It is Java, so it looks like it looks. The class has a very strict responsibility. It calculates the amount of error in the given amount of items, and it can also display the results in a pretty user-friendly manner, so as a string, as double, or anything you want. You would start to develop this simple class most likely by writing a test, and here is how the test looks like. I will once again refer to the things which was said by Bartek and Pavel. This test tries to be readable. Yeah. So who of you is using given when then template in your tests? Yeah, quite a few of you. So I am not very wrong in this in my own practice. And it seems that you are also using JUnit, so it also proves my point to some extent. So we are, in first place, we are creating an instance. We would like to invoke the method which we are testing, and we would like to have some assertion. So basic thing. And as you see here, we are passing some values, and we are asserting, we are checking the behavior of our class for those values. So we would like to be sure that this class will also work for various different kinds of input. So my first idea when I encountered this problem several years ago was to, I can create a table, an array, I could put some values there, and I am so fluent in Java that I know how for loop works. So this was my first approach to so-called data-driven tests or parameterized tests. So as you see here, the code doesn't even pretend to be readable, it is simply unreadable. And apart from this, there are also other disadvantages of this approach. So if you would run this test in IDE, you would see the whole thing as one test. If one of the instances will fail, you will see, you won't have any information regarding different instances. So this is an approach which we don't want to use, and we'll definitely need to find something different. And since quite a while, and JUnit also has an implementation of parameterized test. The thing which was in TestNG since its beginning, the thing which is in Spock since its beginning, because these are younger frameworks, was also added into JUnit. And in order to use this kind of thing, I want to try to jump to the IDE. Whoa, it's way too big. Okay. I love how source code looks on those cinema screens. So the first thing which you need to do is to use the parameterized runner. And afterwards, you have this awkward construction, which is in fact awkward because this is Java. So you need to create a source of your input data, and then you need to pass those data into your test. As I'm sure that most of you are aware of the fact that JUnit creates new instance of a class for every execution of a test method. So before executing one tuple of this from this array, JUnit will create a new instance. So we are passing those parameters through the constructor. So we need to create custom constructor. We need to create fields in order to pass those data into, in order to make those data accessible in our test methods. And the test method itself is quite readable. So we need to, in fact, have quite a few lines of code which are, in fact, serve only to the purpose of passing those data into test, which is not a good solution, and we would like to look for something better. Nevertheless, parameterized is, in fact, a working implementation of parameterized tests. So when we would run this test in IDE, we would have information about different tests which will be executed. We will have information about which assertion fails, and this was our one of our requirements for choosing a data-driven or parameterized test tool. But we have a lot of boilerplate code, and the main, or maybe even the biggest disadvantage of this approach is that you can only have one instance, one thing annotated with parameters in your class. So it is not a nice thing. After reviewing several tools, we ended up with using JUNIT-PARAMS. JUNIT-PARAMS is cool in many different ways. One of those things is that JUNIT-PARAMS is made in Poland. It was created by Paweł Lipiński, and it has several contributions also from other people, and it's really worth to add this dependency to your project. So how does JUNIT-PARAMS tests look like? What is really really useful and nice is when you go to the JUNIT-PARAMS website, you will see the JUNIT-PARAMS showcase, which is only one class. It is quite concise, and you will see all the basic user scenarios there. So in first place, we need to use runner. The name of the runner is JUNIT-PARAMS runner in this case, and we have different ways to inject parameters into our tests. So in the basic thing which is used for that purpose is the parameters annotations. You can do, and in this case, we do not have to create custom constructor. We are adding those parameters to the method itself. So as you see in the first place, we are adding those values as strings, which is not very nice, but for this simple case, it serves the purpose quite well. And the JUNIT-PARAMS does the mapping thing between the things which are in string and typed parameters of our method. That's one approach. We can also create methods which, by convention, should start with parameters 4, and after this prefix, we need to comply. We need to have exactly the same name as the method, as the test method, which we would like to exercise with our parameters. Here is also one interesting thing which is added by JUNIT-PARAMS. No, we are not in JavaScript world yet, but it looks quite nice. It looks a bit like jQuery. Anyone knows what it is? Apart that this is a $sign. I know that. This is in fact a static method which is imported from the JUNIT-PARAMS class. And the thing this method does is to wrap this invocation which we have here into appropriate structures which might be used to feed the data into test. So what goes next? We can specify several methods to provide data to our test. As you see here, I guess most of you have noticed that this is a string. Yeah, once again we have a string. So what will happen if we rename the method? Most likely IDEs like IntelliJ will be able to catch up, but you need to remember about this. On the other hand, this is a test, so we have some we have a rapid way to test how it works, and we can correct this because we will very quickly see that something is wrong. But when I saw those strings here, I started to look for the something which is more Java way of doing things. So we want to have a statically typed provider, and in fact, you can specify a class which will provide parameters for test. And this is not yet all. As I said, JUNIT-PARAMS is quite a flexible thing. So we have also other ways of injecting parameters. Here you see the examples of injecting raw data, in fact. So you can pass a CSV file into your test, whether it will be a CSV file for the specified particular path, or it will be simply looked up in the class path. You can also provide a mapper class which will convert those data into the object which is injected into the test. I encourage you to take a look at JUNIT-PARAMS. It is, as I said, it is really worth to include this dependency into your project. It is clearly visible in the IDE what is going on, which test fails. So it gives you nice feedback, and it is also quite flexible. So JUNIT-PARAMS gives us this parameterized test, this data-driven tests, so we can exercise our system on the test with much bigger set of data. I wanted to show you one more thing, which is similar to this, because JUNIT-theories are in fact parameterized tests. It is something a bit different because it features different approach to testing. When you are writing unit tests, at least when I am writing them, I'm more focused on cases. So what will happen if this object will be null? What will happen if this object will be maxint? These are simplification, but most likely those unit tests which you have in your test suite are documenting features or particular cases. In JUnit, theories is originated more from the concepts introduced by ScalaCheck or QuickCheck, which is an Erlang testing library. We are focused on the requirements more. It is not exactly BDD style requirements. I will show you an example in a minute, so you will see how it looks like. But in fact, just to briefly introduce you before showing the code. theory describes the features of the class. Theory is in fact executed as one test in opposition to those tests which I've shown you with JUNIT-PARAMS. If assertion fails, if even one assertion fails, the whole theory also fails. So I will show you an example of the code. And this is how it looks like. So we are, once again, need to use a different runner. We need to use theories runner, as you see here. And with this comes two additional annotations, data point and data points. You can annotate particular fields in the class with a data point annotation. And you can use also data points annotation to annotate arrays of values. Instead of tests, we are using theory, but this is more or less clearly visible from this test. What is going on here? If I would try to run this one, hope that it will work, you see that the whole test, as I said, exactly the same as with different approaches to parameterized test, the whole test was run several times. What JUnit theories are doing, they are taking all the values which we specified in data points and putting them in all possible combinations into our test. And as I said, JUnit is more about specifying features of the class. So as you see here, we are making, like in every theory, we are making some assumptions regarding the input data. And assume true and also assume false, which are available in JUnit, works the condition which is specified here. If this one will be satisfied, the test will be run. The test will run. If those conditions are not satisfied, the test will be ignored, exactly the same as if you would add ignore here in your ordinary test. So this is a bit different approach, as you see, and it offers you a chance also to exercise your class against much broader set of data. And in fact, you can, in theories, you could fed your test with random data, but the theories itself doesn't provide you with the infrastructure which would give you a chance to introduce repeatable randomness. What I mean by repeatable randomness, it sounds a bit awkward maybe, but imagine that we are feeding random data into our test, which is more or less what users are doing. We would like to have a chance to repeat the situation in which our class would fail. So we would like to introduce both randomness in terms of different arguments coming into our class, and we would like to have an infrastructure which would allow us to repeat the same case in case something would go wrong. And for that purpose, we can use randomized unit testing. This is the library which was written by David Weiss, free and open source, and what the randomized unit testing tests look like and what they are doing. So here's an example of a class. It is quite simple. We are adding two numbers, as you see here, with two random numbers. This is the class which is doing the addition. And we are asserting that each element, each argument is lesser than the final result. But certainly, I guess I'm sure that some of you are already aware of what is the problem here. In some cases, those tests would fail. Any idea when? Yeah, integer overflow, exactly. And in that case, if we would have an information from our continuous integration server that something failed, we would like to repeat this. And for that purpose, you see here that it is here, that number, that long string, this is the seed which was used to generate random numbers. We can take the seed, add seed annotation, and repeat the same conditions for our test. And that is one thing which is cool about randomized unit testing, about the library itself, but it has also other things which are, in my opinion, quite interesting. It also gives you a set of annotations which allows to check whether what is going on in terms of background threads. Our test might create new threads, might add, and what we would like to assert is that after the test is finished, all the background threads or the threads which are created are not active anymore. So how this looks like in practice. I will remove some things, remove some Java Baroque, and here how the test looks like, the basic randomized test. So you need to extend the randomized test in order to have the whole infrastructure which allows you to generate random numbers and random things. This also comes with the add repeat annotation. So if you would like to repeat this test for several times, you can specify a number of iterations here. What is also nice with this one, so if we would have this seed, okay, the purpose of the repeat annotation in this context is that imagine that we have a case which causes problems, which cause that assertion will fail. We would like to repeat this test for a particular seed for several times to ensure that the seed is the source of the problem. So this is how we can start this here. I will add the thread things once again. So we can specify the thread leak scope here. So if the unit should guard if all the threads should be finished by the end of a test, by the end of the suit, and we have also other things to say what should be done in this situation, whether this should fail the test, whether it will just display the warning. So we have plenty of, we have several options here, and I think that is worth to at least add this annotation to see what is going on when you launch your test. So the next thing, which is quite interesting and worth to know, are the rules. So in JUnit 4.8 introduced the concept of the rule and the rule API. What the rules are is that it is a sort of, it is something like before and after set up a teardown in the JUnit test, but it is more reusable and you can certainly do more. Some people say that this is the sort of aspect-oriented programming for the JUnit, and in fact it is very useful when it comes to integration of JUnit with different frameworks. So we have several built-in annotations in JUnit. We can use expected exception rule. We can use the expected exception rule just to make more complex assertions on the exceptions which are thrown from the test. This one gives us access to the test name, and there are also other ones. So here you see the temporary folder rule. I am sure that many of you wanted to create a file or a folder just for the purpose of a test. And the temporary folder rule works like it gives us access to easily create files, and also keeps the record of them. So it removes them when the test is over. As you see, the rule is specified by this annotation, and in the rule itself, this annotation works only for regular fields. If you would like to, for example, use rule in your B4 class, which it implies that the field should be static. And as such, in this case, you need to use a class rule for that purpose. And as I said, the rules are a perfect tool for integrating your JUnit test with external tools. Here you see the example of using Betamax library. Any of you had the chance to use Betamax? Yeah, I thought so. One hand only, my former colleague. The thing is that Betamax allows you to record the REST interactions. So imagine that your service relies on the interaction with the external REST services. And in order to test your service, you can record the response which you receive from that external service, and record them on a tape, and then play it to run your test. So this is quite neat, I could say. And the whole thing is done inside of the recorder rule, which is coming from the Betamax library. Another example, using the JUnit rules, Spring context comes with its own rule. So if you would like to instantiate the context, the Spring context for the purpose of your test, this will be no longer a unit test most likely, but rather a sort of integration test. You can do that by using rule, not only by runners. And here, as you see, we are also using wiremock. Wiremock is something similar to Betamax. It gives you an access to a very nice API, which allows you to stop HTTP responses. So if you like to test your application against HTTP requests and responses, you can do that with the wiremock. And what is going on here, you see that we are specifying the port. Wiremock underneath is using a Jetty web server to mock and proxy those responses. And we are everything which we had to do is just to add the rule. Another example is to use JUnit test cases as a benchmarks. There is a library called JUnit benchmarks, which allows you to which gives you all the necessary tooling for this. So as you see here, we have a method which is run, and we are adding the benchmark rule. And what is going on here? Benchmark rule runs this test for, in fact, 15 times. It takes 5 rounds to warm up the JVM to have more objective measurements, and afterwards it measures the time which the tests lasts. Apart from this, we have also access to additional informations regarding the garbage collector activity, for example. And what is also, and all this comes thanks to the fact that we are just adding this additional rule here. Quite nice in my opinion. What else comes with this particular library is that we can plot these nice charts for our benchmarks and also have a persistent history of executions. So this comes almost for free thanks to the rule API. I will skip the exception handling. Some of the exception handling in a test itself in the unit is quite limited. You can only specify in a test annotation, you can only specify what kind of exception should be thrown. But the expected exception rule allows you to also add more detailed assertion, for example, on the message, which is inside of the exception. So this is also quite neat, and this is the thing which is built into the unit. You do not have to add any dependencies. So the new assertions, why I'm saying new, because when I'm taking a look in the different codes, source code, which are of the unit tests, a lot of people are still using assert true, assert equals, and these are not very semantically nice assertions. And since 4.7, JUnit 4.7, we have Hamcrest, which is built into JUnit, so you don't have to add any dependencies. You don't need to add Hamcrest as a dependency. The Hamcrest is there for you, and the asset that allows you to create more readable assertions. Yeah, so it's a very nice fluent API, which allows you to say what you want, what you expect from the test. There is also an alternative approach. As I've learned over the last few months, it is in fact the more mainstream one, because AssertJ is the much more dynamic project. It is dynamically developed at the moment, and the purpose of AssertJ is to add as most assertions as possible in order to have a rich way of expression assertions about tests. So as you see, the API is a bit different. We are no longer chaining methods inside of the method invocation. We are creating this kind of fluent chain of invocations. Just to explain, the FEST and AssertJ were in fact the same project in the past. AssertJ is a fork of the FEST, which is now much more active than its predecessor. So one more thing, as the ending feature of JUnit, in several projects which I was working in, I had a situation when I needed an external resource for my tests. These were not unit tests; these were rather integration tests, and this resource was quite heavy to initialize. I'm sure that this is the case which some of you also have encountered, and the simplest solution is to initialize this resource in a before class method in a test. So it is done only once, but we want to have better solution for this. We want to initialize this one for this all tests which needs this particular functionality, and we can do that thanks to the suits. Suits are something which is a bit legacy in JUnit, maybe. And it was exchanged by categories. And nevertheless, suits and rules allows us to create the thing which I'm talking about. So we are specifying which classes goes into the suit, and we are specifying the class rule, which starts the heavyweight server before all the tests are started and stops this one afterwards. As I said, the suits are a bit legacy, maybe a bit antish, but the new way of doing this kind of thing are the categories. Categories are supported by both Maven and Gradle. So if you create a suit or as for categories, you need to invoke it using your build tool. And in order to do so, you need to specify those suits in your build tool configuration. And this is how the categories look like. Categories are in fact using interface markers or classes, but interfaces seems more suitable for this purpose. So we have an interface heavyweight which we can add to test which requires this particular resource. And later on in the suite which gathers all the classes, we can specify, as I said, all the classes and include the categories which we are interested in handling in this particular suite. And the code which goes afterwards is exactly the same as I showed you in the previous slide. It starts the heavyweight server and stops it afterwards. So all the code samples are here in my Bitbucket repository. Feel free to take a look at this. There are much more examples there, because this presentation is was in fact developed together with the free, very helpful Java user groups in Poland, which were so kind to host this lecture in the past. So during the discussion which we had during those meetings, I was adding the content to this presentation, and all those examples are in that repository. So that's all, folks. If you have any questions, I'm looking forward to them. Thank you.
Any questions? Okay, if not, thank you very much for your lecture. Of course, our speaker...
There is a question.
Yeah, we've got volunteer, finally.
Have you tried to work with randomized collection generation?
With the randomized collection, but in what context?
In context of size and elements. Something similar to this randomized test, but with a larger set.
So different sets,
Yeah.
different sizes of
Yeah.
sets fed into the not in not in the random way. I was not randomizing the input. I was setting the input. The length of the input in most of my cases was set. I was just playing with the numbers itself. But this is just one more factor, so it can be included, of course. Yeah, there was another one.
Just one quick question, the randomized test. Would you consider that a good practice to have random input for your tests?
Yeah, I think that it is quite useful practice, I would say, because when you are specifying your own tests, the whole idea about what input data will be taken in comes from you, and this is the reason why why developers feel very comfortable when there is another person looking at their code, that another person can come up with different usages and different values which can be fed into your test. So randomized tests can be also perceived as a sort of learning tool. Yeah? So we are learning things about our code, how it will work. The library itself is used heavily by the Lucene and Solar community, and it was a tool which helped to find a few bugs in the Java itself.
Okay, thanks.
One more question. Great. Really great.
Okay. Do you use mock?
Yes, I use Mockito.
Okay. And what do you mock?
What do you mock? Why do you mock?
Yeah. What and when?
What and when?
Yeah.
When, where, in general, I'm trying to exclude most of the dependencies of my class. I am only trying to create. I am trying to avoid mocking of data of value objects which are used by my class. But this in general depends from the scope of a unit which I am testing, because not in all cases the unit is a class itself. So if for example, package exposes only one public class, I am using to test this class. I am sometimes using also the other classes which are in this particular unit. Does it answer your question?
Yes.
Thank you.